Hello students, welcome to my channel, The Field of Chemistry. I am Vijay Lakshmi. Today we are going to discuss about reduction process in aldehydes and ketones. Reduction process, there are four reactions are there. In that, aldehydes and ketones are reduced to alcohol. Maybe it is a primary alcohol or secondary alcohol. They may ask the question, how do we get alcohol through reduction process of aldehydes and ketones? They may ask. The second one, Clemensins reduction. In this, which is convert to alkene. Which is converted to alkane? It is aldehydes or ketones convert to alkane. So that is a Clemensins reaction. Third one, Wolff-Kishner reaction. So this is actually aldehydes or ketones reduced to alkenes. That is actually double bond. This is a single bond alkane and this is a double bond alkene. The last one, hydrazine with sodium hydroxide. Here you are getting some product. That is the hydrazine of product. What it is? This also it is a alkane process. Okay, now the first reaction, which is conversion to alcohol, that means aldehyde or ketone, any one we are using reducing agent. Here we are using nickel and palladium reducing agent. We are using nickel as a reducing agent and palladium as a catalyst. Rest of that, lithium aluminum hydride also we can use, and sodium with ethyl alcohol also we can use. But here in this reaction, we are using nickel with palladium. So what we are going to receive the product, it is CH3 CH2OH. So this is actually what it is, primary alcohol. Primary alcohol. Already I have mentioned CH2OH, it is called primary alcohol. So how do we get alcohol? Through reduction process from aldehyde. So what is this? Acetaldehyde. So this is the way they may ask the question. So acetaldehyde is reduced in the presence of nickel and palladium. We are getting what it is? Ethyl alcohol. Ethyl alcohol, what it is? Two carbons are available. So naturally C2H5OH. Here this is the way also you can write it. 1,2C2H5OH, ethyl alcohol. Here this is the way also you can write it. So we are getting a primary alcohol. Now the second one, ketone, we are going to check. Okay, now here what we have taken, it is acetone. Acetone is reduced in the presence of nickel palladium. We are getting what it is? CH3, C here OH, here CH3. So that means here what it is? Ketone is there. You just observe here aldehyde carbonyl group changes to hydroxyl group. Here also carbonyl group changes to hydroxyl group. So whenever you are going for reduction process, this carbonyl group only changes to alcohol. So just to remember, reduction process, here we are using nickel with palladium. Palladium used as a catalyst. Okay, now what is the name of this? This is acetone. Okay, now here what it is? See, this is propyl alcohol, or else we can write this is 1, 2, 3. So here 2 propanol, OL. You just mention. So I hope you got it for reduction process. So during reduction process, common convert into alcohol. So what is the reducing agent we are using here? Nickel and palladium. Even we can utilize for what it is. Other than that, lithium aluminum hydride also we can use. Sodium with ethyl alcohol also we can utilize. Next one. Here, in this reaction, it is naming reaction. It is called Clemensins Reduction. So, Clemensin reduction, what we are using? Zinc with amalgam. Zinc with amalgam, that is mercury. Zinc with amalgam with corn HCl. So, what is the product we are receiving? Just you get the trick. What is the reactant, what is the product, what is the name of the reaction, that's all. So if you know, you can bring it on your own. So convert into alkane. Which is convert into alkane? This is what it is, aldehyde or ketone reaction only we are going to check. That is in the reduction process. Now here I have taken what it is, acetone. Acetone means what it is, naturally ketone. This is double bond O, phenol, what it is, carbonyl group is there. So it is acetone. Acetone is reduced in the presence of zinc amalgam with corn HCl. You are getting what it is, CH3, CH2, CH3. So what it is called, propane, because 3 carbons are there, propane. Okay, propane, all single bonds. So naturally ANE only will come. So that is what convert. Aldehydes or ketones convert into alkane, I mentioned. And what is the name of the reaction? It is Clemensins reduction. Okay, you got it. Next one. The subproduct, it is what it is, water molecules we are getting. Okay, next one. The next reaction, it is Wolff-Kishner reduction. Here, which product, which one we are using as a reducing agent? Here using hydrazine. Hydrazine, last ammonia and its derivatives only we have seen. In that ammonia NH3, one hydrogen we removed. In that NH2 group, amino group is replaced by one hydrogen. So that means what is it? NH2 single bond NH2. So this is the hydrazine formula. So what it is going to happen? Aldehydes or ketones, any one we have taken. So aldehydes or ketones convert into alkene. Alkene, it is unsaturated compound which is known as double bond. Okay, so here what we have taken, acetone with hydrazine, that is NH2. Here NH2. Why I have written like this means, here for our convenience to understand, here water molecules, it will move, reduced. So automatically here what you will get, CH3, here CH3 double bond NH2. Okay, now again it will reduced with sodium hydroxide. Sodium hydroxide with ethylene glycol. Ethylene glycol. Here what we are getting a product the same way, CH2, here CH3, here CH3. For our convenience I have written. See, actually what happened, this hydrogen will go to that place. So then this one, it will come here. So what it is, remaining product, it is N2. N2 nitrogen. This hydrogen, it goes. That means CH2, it will take place. So what it is, CH3, CH2, CH3. What it is called? Propane. See here, acetone reduced in the presence of hydrazine, water molecules is removed. So you are getting alkene. First, what it is step, you are getting alkene compound of hydrazine. Then further it is reduced with sodium hydroxide. There you will get alkane, ANE, single bond. So first thing you are getting a double bond. Again it is reduced with sodium hydroxide along with ethylene glycol. You are getting propane, which is called what it is, alkane product. Okay. This is Wolff-Kishner reduction. You just note it. Wolff-Kishner reaction means what it is. It is convert into alkene, again further reduced into alkane. What are the things we are using as a reactant? Acetone with hydrazine. Here you are getting alkene compound. Just you remove the water molecule, you bring it as it is. Then again it is reduced with sodium hydroxide along with ethylene glycol. You are getting a proper propane in the form of alkane compound you are receiving. Hope you got it. Here one more compound we are going to take. It is actually a ring structure, but it is not a benzene ring structure. Here inside there is no alkene bond. Okay, now here we have taken this compound. It is what it is, actually keto compound. Okay, ketone carbonyl compound it is available. So hydrogen with sodium hydroxide, hydrazine we have taken. So wherever it is carbonyl group, it is reduced in the part of alkane, ANE, single bond it is taking place. The same way here also alkene also it is taking place. Alkene part, that means double bond, here we have taken one more compound, and this also what it is in the presence of hydrazine with sodium hydroxide. Here wherever it is a carbonyl group, there it is changes to CH2, that means alkene compound it is reduced. Okay, you just remember that because these two questions are important. It is asked in the CET and IIT question. Choose the correct answer they have asked. You just go through that, you will come to know. So in the reduction process, with the presence of hydrazine, you will get a carbonyl compound changes to alkane compound. The next one, what we are going to check, it is oxidation process. So long we have seen the reduction process. Now we are going to see the oxidation process. Oxidation process, there are 5 reactions are available. In that, oxidizing agent, you know very well oxidizing agents. What are the oxidizing agents? Means number of things you can tell. In that, one among that it is potassium permanganate, KMnO4 we have taken. Then second one, Tollens reagent. Then third one, it is Felling's reagent. These and all you will learn in the practicals classes only. Then with the alpha hydrogen. With the alpha hydrogen, I think in IUPAC name what I have taken that video, no? In that it is available very clear idea about what is it alpha hydrogen I have given. No problem, here also I will explain what is alpha hydrogen. You just check it. Then with the reaction of alpha hydrogen or without alpha hydrogen, how it is reacting, that is oxidation process. These are the 5 things we are going to check along with the naming reaction. It is interrelated. I will come while explaining. Usually oxidation process with the help of oxidizing agent is what it is, potassium permanganate. With the help of it is oxidized, that means what is this, it is acetaldehyde. Acetaldehyde. Okay, acetaldehyde oxidized in the presence of alkaline KMnO4, you are getting acid. So CHO, it's a functional group of aldehyde, you know very well. Now we are getting COOH. COOH, what is the functional group? Of course, it is a carboxylic acid functional group. So here what we are getting, CH3 COOH. CH3CHO changes to CH3COOH. That means during oxidation process with the help of KMnO4, that potassium permanganate, acetaldehyde changes to acetic acid, CH3CHO, acetic acid. So they may ask the question, how do we get the acid? Help of aldehyde, how can it will change? For example, acid convert into what it is, aldehyde convert into acid. Give the example. So aldehyde convert into acid, that is acetaldehyde convert into acetic acid, that is oxidizing product with the help of alkaline KMnO4. That's all. 2 points is enough. 2 more question or 1 more question they may ask. Next one. Okay, the next reaction, it is Tollens reagent. This is actually you will learn in the practical. Acetaldehyde reacts with Tollens reagent. What is Tollens reagent? Here silver is there and ammonia. ammoniacal silver nitrate. I think you might have heard about in the practical classes. Okay, so tolerance reagent is nothing, ammoniacal silver nitrate. It is prepared by taking a drop of silver nitrate and adding sodium hydroxide into the given brown precipitate of silver oxide. You will get it, that will be dissolved in the ammonia to form a complex. So that is called what it is, ammoniacal silver nitrate. So this is active in the presence, actually this is called tolerance reagent AgNH3 twice plus. Okay, now here what do we get here? Acetate. Actually here CH3COO minus compound we are getting, and then it is a black precipitate of Ag, that is oxidized product we are getting. So this is the reaction of oxidation. Okay, so in the tolerance reagent, what is the tolerance reagent? That is nothing, ammoniacal silver nitrate, that you have learnt in the practical classes. The next one, Felling's reagent. This is actually Felling's reagent. Felling's reagent is nothing, copper. It is actually Felling's solution is known, it's a cuprous oxide. Aldehydes or ketones is heated with the Felling solution. It is, we are getting a red precipitate of cuprous oxide. Here this is a cuprous oxide, red precipitate we are getting. It is a reduced compound, and acetate ion which is coming here. Acetaldehyde changes to acetic acid in this minus compound. It is H plus ion and CH3COO minus ion. This is a Felling solution. Okay, next one. I'm going to take practical video in a different way. In that time, I will tell how to prepare Felling solution and whatever reagent, easy to freshly prepared solution. That time I will tell you how to prepare that Felling solution. Right? Next one. Okay, so long what we have seen, it is aldehyde, that means acetaldehyde oxidized to acetic acid, or acetaldehyde in the presence of tolerance reagent or Felling's reagent, it changes to acetic acid, that is the acid ion we are getting in such a way. Now ketone we have taken, this is aldehyde and this is ketone. Ketone is nothing, acetone only. So here ketone is oxidized, we are getting what it is, acetic acid. See here actually, here acetone, that means 3 number of carbons are there, but while what it is oxidized, and we are getting a form of lesser number of carbon atoms. Here 3 carbons are there, bond breaks over here. So here at actually what it is, OH, it is oxidized like that, CH3COOH plus H, that is water and carbon dioxide. In such a way it will change due to that oxidizing process. So usually aldehyde changes to acid, the same number of carbon will be available, but when it comes to ketone, lesser number of carbons will be available, that is also changes to acid only, acetic acid or whatever it is, CH3COOH, it is acetic acid. See now here for example propanone, 4 carbon atoms will be available. So along with this is propanone only. So butanone for example 4 carbons will be available. In that 4 carbon, maybe lesser number of carbon, maybe 3 carbons may be available. In such a way you will get the product. You just remember ketones are oxidized to get a product of acid which is lesser number of carbon when we compare to the reactant of ketone. Hope you got it. Next one. Here actually one more thing I would like to tell, this is actually more number of carbon is available, here lesser number of carbon product we are receiving. This is actually what we can say, it's a Poff's rule we can say. Here acetone it is there, here acetic acid only 2 number of carbons are available, here 3 carbons are there, here it is a cleavage takes place. So CH3CO OH here and this is H. So here carbon dioxide and water molecule. So this is actually, what is that name of that? Puff's rule. Puff's rule means Puff's rule, you can say. Puff's rule, it is actually what it is. More number of carbons of ketone oxidized and give the product of lesser number of acid. So ketone changes to acid during oxidation process. That is a common. But more number and lesser number, it is the difference. So more number of ketones oxidized and we are getting the product of lesser number of acid. Okay, you got it. Okay students, hope you got it all this reaction method of oxidation and reduction. Next video, I would like to discuss with you all about the naming reaction, which is very very important. Naming reactions, that is Cannizzaro reactions and what it is, aldol condensation, Perkins reactions, fatigue reactions, all this namings reaction I am going to explain. Please watch this channel. Subscribe your this channel and you will get all my videos updated.